B1 plus B2S. Sama-sama scroll sikit free body diagram tu. Sekejap. Habiskan ni dulu. K1 plus K2 Y1 minus B2S plus K2 Y2, buruklah Y ni. Y2 equals B1S plus K1 Y0 S. Okay. So this is equation number 2. So you can arrange them in matrix, or you can leave it like this. Okay. But if you arrange in matrix, then you can continue with using Cramer's rule. Okay. It's easier. But if you think you use, if you want to use by substitution, sekali lah, okay. But Cramer's rule senang sikit. Tak payah simplify pun, okay. Selalunya soalan transfer function ni kalau tinggal sampai in the form of determinants without simplifying the determinants, it should be okay. Selalunya hilang satu markah je. So when you answer in terms of determinant using Cramer's rule, so you are confirmed to get to get some marks from there. But if you use by substitution, probably the examiner will look for the final answer, okay? The answer with after you simplify everything. Sebab sometimes bila guna substitution terlalu panjang jalan kira, so panel pun pening mana satu jawapan. Panel examiner malas nak tanda. Kita orang pun malas macam korang juga. So kita orang malas nak tanda, so kita tolak je lah 3 markah ke macam tu. Rasa macam student tak jawab ke gitu. So kalau jawab dalam bentuk determinant, nampak dah oh ni jawapan dia, bagilah 2 markah macam tu. So kalau jawab by substitution, bila panjang sangat, kita orang assume student tak jumpa jawapan macam tu. So kita bagi 1 markah ke, kadang tak bagi. Okay. So when you get in terms of this equation, so you get 2 marks, okay. So 1 markah kat atas, 1 markah kat bawah. Okay, boleh nampak free body diagram? Okay, so after you write the equations, try to arrange in matrix. So in matrix, it will become M1S squared plus B1 plus B2S plus K1 plus K2. And here will be B2S plus K2. Okay, so equals, so this one, so B1S A1 Y0 S zero. Okay. And the question B asks you to determine the transfer function y2 over y0. So basically you are required to find y2. So y2 equals determinant of M1 S squared plus okay, divided by the original determinant. Okay, ni saya malas tulis, okay. So when the question asks you to find y2 over y0, try to simplify the top only pun okay lah, okay. So you should get y2 over y0 equals determinant this one, and this part becomes k1, okay. So kalau ada dalam bentuk y2 y0, dapatlah kalau dapat susunnya atas ni satu markah kat atas. Kalau ada bentuk y2 over y0, dapat lagi 3 markah, 2 markah lah. 2 markah. Kalau simplify kan 1 markah, okay. 1 markah untuk simplify. Okay. So this one basically it's the properties of determinant, okay. So the properties of determinant basically kalau if you look at this column, you can factorize each column or each row separately. So here you can factorize y0, and this column since it's 0, so basically you can factorize y0 y0 keluar, okay. Difference with matrix. So if matrix, let's say matrix awak 2, 4, 6, 8. So here you can factorize 2 darab 1, 2, 3, 4. But for determinant, kalau determinant 2, 4, 6, 8, you can factorize 2, 1, 2, 6, 8 macam tu. So you can factorize by column, okay? Column by column. But for matrix, if you want to factorize, you must factorize all elements at the same time. But for determinant you can factorize by column or by row. So dia boleh jadi macam ni ataupun boleh jadi 2, 1, 3, 4, 8 macam tu. Tak belajar kot. Tapi beritahu je lah. Okay, so soalan ni 10 markah. Doktor, saya ada soalan. B2 friction act as damper? Yes. Tu ke soalan? Mana tadi? Okay, B2 friction. So friction dengan damper dia punya the concept for finding the force is the same, okay? For friction and damper. Kalau FAD salah dari awal, yang M2 dapat berapa markah ya? So usually for free body diagram, let's say if 2 marks here, selalunya 1 markah dekat force atas, 1 markah dekat force yang ke bawah. So one mark for upward force, 1 mark for forward force. Kalau salah satu contohnya, pandai-pandailah bagi 0 ke 0.5 ke. Kalau ni ada 3 kan, macam downward force ada 3, contohnya salah satu, bagilah 1/3, 2/3 ke. Pening kan nak decide markah berapa? Macam tu lah lecturer. Ni macam kira praktis lah macam mana korang nak jadi lecturer. Kalau nak jadilah. So kita orang pun tak tahu macam mana nak bagi student jawab salah. So kalau katakan salah ni 1, 2 betul, bagilah 2/3 ke, ataupun bagi 0.6 ke, 0.7 ke. Kalau saya, kalau dalam exam, kalau salah satu saya selalunya bagi 0.5 je terus. Ada kadang-kadang lecturer salah satu dia bagi kosong je terus. Okay, dia macam nak kena betul lah gitu. Selalunya kalau dah salah sini, bila kira equation, for the equation of motion part, kita orang tak tolak markah dah, unless sini salah, sini tak ada B2Y2 dot, tiba-tiba sini ada B2Y2 dot, itu kita orang bagi kosong terus. Maksudnya macam tipu lah, tadi tak ada, tapi dekat equation of motion ada pula B2Y2 dot, dekat free body diagram tak ada. Kita bagi kosong terus dekat equation of motion. Tapi kalau korang continue, walaupun salah sini, but still continue with the same free body diagram, equation from the same free body diagram, kita orang bagi je full mark 2 kat sini, 2 kat sini. Maksudnya markah hilang dekat awal tu je. Okay, faham. Terima kasih, Mama. Okay, kita tengok soalan gear pula. Okay, so for this question, so I told you last class that for this kind of question, you need to introduce new degree of freedom, okay? Because here it only gives you theta 2, okay? But actually you need to introduce theta 1, okay? Ayo. Theta 1, alamak, besar pula gambar. Okay, theta 1 kat sini. Okay. Sometimes the question gives you the degree of freedom, but sometimes the question only gives you the important degree of freedoms only. Macam ni soalan ni dia nak theta 2 over t. So dia bagi theta 2 dengan t je lah. Theta 1 sebenarnya ada. Tapi dia tak nak cari pun, dia tak nak you cari theta 1, dia nak you cari theta 2. So buat apa, dia tulis macam semak aja kat situ. So korang kena introduce sendiri. Okay, so to introduce degree of freedom, basically kalau ada rod kat sini, introduce lah, maksudnya kena ada degree of freedom lah dekat rod. Macam ni dekat sini ada point dekat sini that is connected with springs and dampers and are separated from the rod. So you have to have theta 2 here, degree of freedom here. Okay, so let's do free body diagram for theta 1 first, okay? Okay, so on theta 1 you have the torque T. So we assume the torque is in the same direction with theta 1, okay? And then on theta 1 also you have spring here and damper here connected to theta 1, connected to rod, okay, the rod directly, okay? So these two spring and damper are not connected directly with the rod. So dia bukan sebahagian daripada rod, okay? Dia tak menyebabkan forces on the rod. So you have spring 1, theta 1, Theta 1 je lah. And another one is theta 1 dot. Direction salah. And then the spring and damper are also connected with theta 2. Okay. So two more forces by theta 2. So you have theta 2 dot. Okay. Ni dah substitute, okay, value dia. Jangan tanya pula, so kenapa tak ada value depan ni? Pandai-pandai lah. Okay, so let's look at tertinggal satu dia punya inertia. So inertia theta 1 double dot. Okay, 2 markah. Okay, let's look at theta 2. So on theta 2 you have two springs and two dampers connected to it. Okay. So kita tengok kat spring dulu. So spring theta 2, damper theta 2 dot, another spring theta 2, and another damper theta 2 dot. Okay, so the first spring and damper is also connected with theta 1, the rod theta 1. So you have two more forces acting clockwise, okay? So here theta 1 and theta 1 dot. Okay, so 2 markah. So bolehlah tulis equation of motion. So here theta 1 double dot plus theta 1 dot plus theta 1 minus theta 2 dot plus theta 2 equals T. So ini equation 1. And equation 2 banyaknya. Negative theta 1 dot plus theta 1 plus theta 2 2 theta 2 dot plus 2 theta 2 equals 0. Okay, and then tulis dalam frequency response. So you get theta s squared plus s plus 1 theta 1 minus s plus 1 theta 2 equals, and then this one becomes s plus 1 theta 1 s plus 2s plus 2 theta 2. Okay, so ni 2 markah. Okay, satu atas, satu bawah. Okay, and then boleh tulis dalam matrix. Okay, so after this, you are required to find theta 2 over t. So basically, you need to find theta 2, okay? So theta 2 equals determinant s square plus s plus 1 minus s plus 1 ps 0 over determinant ni. Tulis saya. Tulis tau, jangan tak tulis. And then if you write theta 2 over t, so this one becomes negative S plus 1 over determinant tadi. Okay, so if you have this jalan kira ke, okay, jawapan akhir 1 markah. Tadi dah 6, okay, ni 3 markah lagi. 3 markah ni jalan kira. Tapi in the end dia nak ni, okay. Okay, any question before we go to the next lecture? Sir, tak payah bubuh J dengan D ke? Oh, bubuh tapi dah ganti. Sebab J dengan D tu kan satu. Kalau tak nak tulis banyak-banyak kali, ganti terus pun boleh. Sir, midterm bila? Bila hari tu? Alah, lupa lah. Hari Khamis, pukul 8 malam sampai pukul 11 malam. Weh, sendu gila malam. Lepas tu, bila lah? Alamak. Somewhere December kot. Minggu 3, 4, 5, 6, 7. Ni kot, 3 Disember kot. Tapi belum finalize lagi. Sebab biasalah dia orang ni. Macam-macam, nanti tukar last minute. So midterm, soalan pun tak buat lagi. Perform lah Bond. Bond perform. Super Bond. Pada hari ni baru perform. So midterm usually keluar sampai rasanya SEM ni keluar sampai di Simoto. So di Simoto nanti next week kita masuk. 2 soalan 20 markah lah, 20 markah. 20%, but question will be 2 question. Each question 25 marks, okay? Tak decide lagi soalan apa, tak buat lagi. Bukan saya buat. So kalau bukan saya buat, soalan dia susah tiba. Nantilah, sabar Bon. Nak jawab test je, tak nak belajar. Okay, kita masuk new lecture, okay. Okay, so alright, so lecture 2F basically about the transfer function of rotational mechanical system, but this time with gears, okay. So in lecture 4, in quiz 4, you have learned about rotational system without gears. So that lecture basically is just introduction to you how without gears, how system without gears, how to determine the transfer function for system without gears. But commonly in exam, you will be asked a system with gears, okay? Okay, so in this topic, students will be able to create transfer function of rotational mechanical system with gearing. Okay, so ni recap. Okay, saya tak tahu kenapa ada slide ni, dalam slide ni. So for translational motion, basically it's linear motion. So you have a spring and damper. So the spring and damper here, we call it linear spring and linear damper. And for rotational motion, basically it involves rotating bodies, and you can connect the rotating body by some linearly moves, something that can move linearly, okay? Macam ni dia guna apa benda ni, tali sawat, timing belt. So mungkin student automotive pernah jumpa kot komponen-komponen ni. Tak tahulah, saya assume je. So spring, for linear spring kita ada spring yang bentuk yang selalu jumpa dalam pen, dalam pencil, tu linear spring. And for rotational spring, mungkin selalu jumpa dekat spade kain, okay? Spade kain apa bahasa Inggeris? Tak ingat. Dekat apa lagi yang dalam ni? Gitulah, okay? And then damper yang selalu jumpa dekat pintu. Yang pintu bila buka dia tutup sendiri. Tu damper, linear damper. Untuk yang rotational damper, I don't know. I never seen this before. Maybe you guys have seen this somewhere in labs ke. So gears are basically a machine with tooth, okay? Dengan ada gigi or bergerigi. Tooth machine part such as wheel, cylinder that meshes with another tooth part. So gear must mesh with another gear to transmit motion or to change speed or direction. So kegunaan gear basically dia boleh transmit motion dan juga boleh tukar direction or speed of some rotating things, okay? Macam dalam kereta lah, ada gearbox kan. So you have gear 1, gear 2 until gear 5 and then reverse gear. So when you change this gear, so your car will move faster or slower, or it can reverse in direction when you change to reverse gear. And there are many gears. So this is the regular gear here, rotational gear. So you have also translational and rotational gear here. Satu lurus, satu berputar. And here we call it bevel gear. Bevel gear. Tak tahulah dah belajar dalam MACD ke. So bevel gear ni selalu jumpa dekat pintu kedai. Pintu kedai yang besi tu, sebelum dia orang nak tutup kedai terus, dia orang tutup yang besi tu kan. Yang tarik dari atas yang bunyi krrrr tu. Yang tu dia guna bevel gear. Saya tahu pun sebab belajar masa degree. Kalau tak tahu. Acah je macam knowledgeable, padahal hampir. Okay, so fundamental properties of gears. So the two gears turn in opposite direction. So when two gears connected together, so one gear clockwise, the other gear rotates anti-clockwise or counter-clockwise. So dia tak boleh pusing the same direction lah, okay? So one gear rotate clockwise, the other must rotate counter-clockwise. So two gears revolve at different speed depending on the number of teeth on the gears. So speed of the gears depends on the teeth of gears. So kat sini gear A pusing clockwise, dia sambung dengan gear B, so gear B pusing counter clockwise. So gear B dengan gear C connected juga, tapi dia connected by a linear rod kot, ataupun kita boleh kata gear B and gear C are on the same axis, okay? On the same axis. So the rotational direction are the same. And even the speed, I think the speed are the same. Nampak macam tak sama, tapi sepatutnya sama. And then gear C connected with gear D. So gear D will rotate in reverse direction. Okay, so here we call it gear train. Okay. Gear train basically is arrangement of gears yang banyak. Okay? So gear train basically meaning many gears. Okay, so it is called gear train. So gearing up is able to convert torque to velocity. The more velocity gain, the more torque sacrifice. The ratio is exactly the same. If you get 3 times your original angular velocity, so you reduce the torque to 1/3. Saya tak pandai pasal kereta, but example yang paling senang ialah kereta lah. So macam nak naik bukit dekat Janda Baik sana, yang bukit yang lepas tol tu, tak tahu ingat tak? So nak naik bukit tu korang kena turunkan gear ke gear 1 ataupun gear 2. Sebab gear 1, gear 2 ni speed dia rendah tapi torque dia tinggi. So nak naik bukit ni kena torque yang tinggi, okay? Kena force yang tinggi lah. Tapi bila dekat jalan lurus, for example dekat Temerloh ke, jalan yang panjang sampai mengantuk tu, so korang nak bawa laju, nak speed lah. So korang guna gear tinggi, gear 5 ke, gear 4. And then for higher gears, you have high speed but the torque is very small, very low. So gear tinggi ni tak boleh guna untuk naik bukit lah. Boleh je, tapi dia akan jadi lambat dan kereta tu macam tak boleh nak pick up speed. Okay, saya tak minat kereta, jadi jangan tanya pasal kereta. So this conversion is symmetric. We can also convert velocity to torque at the same ratio. The price of the conversion is power loss due to friction. Okay, so kalau nak modelkan gears secara lebih detail, we can model power loss due to friction. Benda ni usually ignored, okay? So friction between gears are usually ignored, okay? Usually ignored. Okay, sebab nanti jadi complicated pula subject ni. Dah memang complicated, bertambah complicated. So why gearing is necessary? A typical DC motor, so kita ada DC motor. So DC motor usually operates at speed that are far too high to be useful. So we must reduce the speed of the torque of the DC motor so that it can move larger objects, okay, like wheels, for example. And DC motor usually has high speed but low torque, okay. So you must increase the torque, okay. Increase the torque of DC motor by adding gears on the DC motor. So to allow for gearing, I mean to calculate the increase or decrease of torque and speed due to gears, we call a method of gear reduction, okay. Gear reduction method, which is a standard method by which a motor is made useful. Okay, tak keluar lah exam. Kenapa guna gears? Tak ada. Okay, so this is gear train that I explained just now. So you can calculate the gear ratio by using the number of teeth of the driver divided by the number of teeth of the follower. So gear ratio equals number of teeth of the driver divided by number of teeth of the follower. We gear up when we increase velocity and decrease the torque. Okay, so gear up means increase in velocity. So here, example here, to determine the gear ratio. So let's say gear, the first gear here is the teeth is 8, and the second gear here the teeth is 24. So the gear ratio here is driver divided by follower. Okay, so 24 divided by 8, you get 3. So the gear ratio is 3:1. Nantilah ini. Gear ratio basically number of teeth input gear divided by number of teeth of output gear. Okay, so basically driver here is your input gear, and follower here is your output gear. So number of gear and number of teeth from driver divided by number of teeth of follower also equals torque of driver divided by torque of follower, and also equals speed of follower divided by speed of driver. Okay, ni je equation formula untuk lecture yang ni, okay, untuk gears. hadam. Ingat sampai habis semester. Okay. So number of teeth driver divided by number of teeth of follower equals top driver divided by top follower also equals velocity or speed of follower divided by speed of driver. So you get the gear ratio. Okay, ini dalam kereta. Okay, so mathematical modeling. Okay, so gears increase or reduce angular velocity while simultaneously decreasing or increase in torque. So dengan syarat the energy must conserve. Okay, so to model the gears, basically you use the concept of energy conservation of energy. So the energy of driving gears equals energy of following gears. So to calculate energy, basically the number of teeth times the the angular displacement equals the same number of teeth times angular displacement for the follower gear. Okay, so N1 times N2 theta 2 equals N2 times theta 2. Okay, ni derivation ni tak keluar pun, just nak tunjuk je. Okay. So this is a basic of gearing system. So ada dua gear. Setiap gear ada dia punya teeth, angular displacement and torque. Okay. So how to determine the relationship between two gears. Okay, so distance travel or the circumference by gear 1 must equal the distance traveled by gear 2. Okay, so circumference of gear 1 S1. So ni circumference. Apa dah? Must equals, okay? So S1 equals S2. R1 times theta 1 equals R2 times theta 2. So R here is the radius. And then you rearrange. And then the ratio of radius between gear 1 and gear 2 is equals to the ratio of number of teeth. So R1 over R2 equals N1 over N2. So you get the first relationship here. Okay, which is the same as previous one when you use conservation of energy. Okay, so yang ni kena hafal lah. N1 over N2 equals theta 2 over N theta 1. Assume work generated. Okay, ni pakai work. So work you use theta 1 times theta 2, theta 1, T1 times theta 1 equals T2 times theta 2. And then this one you rearrange. So ni rearrange, you get this one. Tapi kita tahu tadi N1 over N2 equals apa tadi? Lupa. Equals theta 2 over theta 1. And so this is also equals T1 over T2. Okay. Ni pun kena hafal. Oh, tiba-tiba je. Okay, so yang penting dalam lecture ni ialah N1 over N2 equals theta 2 over theta 1 equals T1 over T2. Okay. Ni kena hafal, wajib. Okay, so let's look at example how to calculate gears, to determine transfer function of gears. Okay, so given a system shown, so usually in exam your gears will be represented by a single line like this. So single line macam ni, gears lah, okay? They're connected, okay? So this one, this is gear 1 and this is gear 2. So fixing the J, so bila you pegang J ni, when you hold J, basically the whole system will not move, okay? When you hold J, then the gear will not move. Okay, macam tersekat. So this system is 1 degree of freedom. Compared to previous lecture, when you hold J, then the other parts can move, still move. But here, when you hold J, the gears N2 cannot move. So basically, gear N1 pun tak boleh move juga. So when you have this kind of system, it is 1 degree of freedom. So the same modeling steps. So first you need to decide input output and then draw free body diagram and then convert into time function, from time function to frequency function, and then obtain the transfer function. Okay, so the input here is the torque T1 and the output is theta 1 or theta 2, okay? Depending on question, dia nak theta 1 ke theta 2. Tapi kalau perasan, the torque here is on this section of gears, but your theta 2 here is on the other section. So you need to do some adjustment, okay, or some gear reduction here. Okay, so first you need to transfer the torque and theta 1 onto the other side, okay. So to transfer T1 to this side, to this section, basically you use the formula that we learned just now. So N2 over N1 equals theta 1 over theta 2 equals T2 over T1. Okay, so this T1 is on this side. So you want to get the torque on this side. Okay, so let's say you call it T2. So how to get T2? So basically T2 over T1 equals N2 over N1. So your T2 equals T1 times N2 over N1. So this is your T2 here. Okay. And then you can also transfer theta 1 to this side. But since you have theta 2 here, tak payah transfer pun tak apa, okay? Nanti kita cerita tu nanti. So when you transfer the torque here, so you can ignore the gear sections, okay? So your system will become only this section here only, meaning it becomes 1 degree of freedom system. So we call this gear reduction method, okay? So from this figure here, we can draw the free body diagram as in lecture 4 or quiz number 4. So here on J, you have damper D and spring. So assume theta 2 counterclockwise. So J theta 2 double dot will be clockwise. D theta 2 dot will be clockwise, and spring K theta 2 clockwise. And then the torque here is from the theta 2 that we calculate will be counterclockwise. Okay, and then you can write the equation of motion. And then write in terms of frequency. Okay, and then if the question asks to find theta 2 as the output, then it's straightforward. You just rearrange, okay? Rearrange theta 2 over T1, then you get the answer for theta 2 as the output. But what happens if the question asks to find theta 1? So our theta 1 here basically is on this side. Okay, but theta 2 dekat sini. Dan bila dah transfer the torque just now, we only have theta 2 here. So you need to use the relationship given here, okay? So let's see how it is done. So you use the gear system relationship. So N1 over N2 equals theta 2 over theta 1. So theta 1 equals, okay, theta 2 equals theta 1 kan. Apa je lah. Okay, so from the transfer function for theta 2, so here it's theta 2. So you need to substitute with theta 1 times n1 over n2. Bila dah substitute, barulah rearrange theta 1 over t1. Okay. So what have we learned here? So bila kita nak cari theta 1, each of the j, d and k has a thing as a gear ratio squared here. So the gear ratio squared here, we call it impedance transfer. Okay. So impedance transfer is the same for each j, d and k. So the k for destination equals k source times n destination divided by n source squared. So apa yang berlaku kat sini sebenarnya, theta 1 dekat sini, tetapi your j, k and d are on this section. So to find theta 1, basically what you need to do first is to transfer the impedance. So you need to transfer j onto this side, d on this side, and k on this side. So to transfer j, d and k, you need to multiply with the gear ratio squared. So here we assume that theta 1 as the destination. Destination means we want everything j, d and k to be transferred to. Okay. So destination ialah tempat di mana j, d dan k dipindahkan. And then the location, the original location of j, d and k, we call it source. And then the n1 here is the n destination. And the n2 here is the n source. So to transfer j, for example, so you use j, the new j destination becomes j times n destination, which is n1, divided by n source, which is n2, squared. Okay. Same goes with d. So d times nd over ns squared. And same for kd. So d also the same. You need to multiply with n1 over n2 squared. A also the same. Okay, kita tengok satu example macam mana nak guna impedance transfer. Okay. So in this example, the question asks to find theta 2 over t1. So theta 2 kat sini, tapi t1 dekat sini. So in this question, when you hold j1, when you fix j1, then gear n1 will not move. Okay. When gear 1 not move, then gear 2 will also stop moving. Okay. So when gear 2 stop moving, J2 will also not move. Okay. So basically when you hold J1, everything will not move. So this is the case of 1 degree of freedom. Okay. So this is 1 degree of freedom. So when you hold J2, everything will not move as well. So it's 1 degree of freedom. So what you need to do first is to transfer the impedance from T1, from J1 to this section. So J1 also transferred to this section, and D1 also transferred to the second section. So let's look at how to do this. So we assume that theta 2. So because we want to find transfunction of theta 2 over t1 over t1, so we assume that theta 2 located in the destination. Okay, so we assume theta 2, the location of theta 2 is the destination, and everything else, basically theta 1 and all j1, d1, and t1 are located on the source. So we want to transfer from source to destination. So first we transfer the damper. So basically you can just add up damper. So DE here we call it equivalent damping, D equivalent equals D2. So D2 we don't transfer, so it remains as it is, plus D1 because we want to transfer D1, so we multiply with n source, n destination over n source squared. So the formula just now, K destination equals K source times n destination over n source square. Okay, so K ni can be J, D, and K, okay? So kita guna simbol K. So to transfer D1 to the destination, so you multiply with N2 over N1 squared. So D2 plus D1 times N2 over N1 squared. So N2 because destination, okay? N2 is the destination. And then we have J1. So we need to transfer J1 as well, okay? So J equivalent equals J2 because we don't transfer J2, so it's already there. So J2 plus J1 times n destination over n source square. So N2 is the destination. It's the n for destination. And then we have a spring. So in the source, we don't have any spring. So we don't need to transfer any spring. So the K equivalent equals only K2. Okay? Plus 0 lah basically. So there is no spring, so you don't need to transfer anything. So K equivalent equals K2 only. So when you have transferred everything, then you can redraw your system into 1 degree of freedom system. So the damper becomes damper equivalent, D1 times N2 over N1 squared plus D2. The spring becomes spring equivalent, KE equals K2. And the J becomes J equivalent, J1 times N2 over N1 squared plus J2. And then other things is you need to transfer the torque. So to transfer the torque, basically T1 over T2 equals N1 over N2. So you want T2, so T2 equals T1 times N2 over N1. Okay, so you get here. Okay, so when you have transferred everything, torque, J, D, K into the destination, then you can draw the free body diagram. So on JE, you have spring and damper and inertia, and then you have the torque. That's it for the free body diagram. And then you can write in terms of equation of motion. And then you can substitute and then rearrange theta 2 over T1. Or if you want theta 1 over T1, then you need to gantikan theta 1, theta 2 equals N2 over N1. Okay. So substitute theta 2 equals theta 1 times N1 over N2. Okay. Ada soalan tak sebelum kita teruskan? Tak ada. Okay, bagus. Semua tidur. Okay, let's look at an example. So example ni tak ada. Oh, ada. Okay, so in this example, the question basically wants you to find theta 1 over T1. Okay. So for this example, T1 and theta 1 is on this section. And the rest, like D1 here is the damper or friction of the gears. Okay, friction of gears. And J1, J2, J3, J4 are the mass of the gears. Okay. So since theta 1 is on this part, so we can assume this as a destination, while the others are the source. Okay. So first you need to transfer everything to the destination. Okay, so let's look at the first gear here, gear number 2. So first we need to transfer D2 on this section, on the destination. So D equivalent. So D equivalent equals D1, which is already on the destination, plus D2 times the gear ratio. So N1 over N2 squared. Okay. And there are no more dampers. So this is the damper equivalent. Okay, now let's look at the J equivalent. So J equivalent equals J1 because J1 is already on the destination, plus J2. So J2 multiply with N1 over N2 squared, plus J3. So J3 is here. So when J3 is here, basically the rotational speed of J3 and J2 are the same. The torque are the same. So basically to transfer J3, you only use the gears on J2. Okay. So you don't use N3. Okay. You use N2 and N1. So J3 times N1 over N2 squared. And then J4 here. So J4 multiplied with N4 over N3 squared. So when you multiply with N4 over N3 squared, N3 over N4 squared, so you basically transfer J4 onto this section only. So you need to multiply with N1 over N2 squared to allow J4 to be transferred on the destination. So you multiply 2 times, okay? So N1 over N2 squared. Dua kali, okay? Dua kali multiply. So plus J5, so same with J5, N3 over N4 squared times N1 over N2 squared. And then from here you can draw the free body diagram, find the equation of motion, and then find the transfer function theta 1 over T1. Okay, so apa dah? Okay, sebenarnya ada lagi lecture, tapi we stop here. I want you to do quiz 5A. So quiz 5A, basically you want to find theta 2 over T, okay? So please note that theta 2 is here on the second shaft, but the torque is on the first shaft. So what you need to do is you define the middle shaft as the destination, while the other two shafts as the source. So this is the source and this is the source. Okay, source dia dekat kiri kanan, dia punya destination dekat tengah. Okay. So how to choose the destination? Basically, to choose the destination, we choose the location of theta that we want to find. Okay. Okay, so quiz 5B kita buat, saya bagi minggu depan. Sebab kita kena tengok exercise tu dulu. Ni minggu depan juga. Okay, so any question before we end our lecture? Siapa pasang lagu? Kantoi. Okay, so if you have no question, then please submit your quiz 5A in the Google form. Also your marks for quiz 3D and quiz 4 and also quiz 3E. Okay, quiz 3E, jangan lupa. And then next week we will discuss quizzes 5A, 3E, and then we will go into gearing system yang kita tak sempat ni. Okay, that's it for today. Thank you very much. Assalamualaikum.
Thank you, sir.
Thank you. Due date bila untuk quiz 5A? Quiz 5A due date dia